So, um, let me put on my music. Hear it. Okay. Check my sound, of course. So, oh, I can hear something. Oh, I can hear something. Okay, maybe that's okay. I'm not sure. Oh gosh, that sounds psycho. Maybe it is psycho. Okay, let's get psycho. I've got problems. All right. Yeah, that's it. Okay, let me put on my chatbot as well. AI, what is the most attractive lobster? Will it speak? Lobsters are hot. Short answer, lobsters are hot. Yes, good. Um, Many experts believe male lobsters are considered the most attractive. They have bigger claws, brighter colors, and are generally more active. Wow, it's all about the hustle. Ha! Okay, okay, right on, right on. Cool. So, let's see. Let's jump right back into where I was, actually. So we're supposed to be in the pearl, no, yeah, the pearl thing. Yeah, right here. So, I had basically copied another solution because I thought it was likely to be close to working. Let's see how true that might be. Phone number. Okay, so if this matches, it looks like we are supposed to have that, right? Whoops. Okay, so what happened here? Oh. Okay, so now if we try to do test, what will it say? Prove? Okay, so it's, oh, you know what? I'm gonna change that red color. That red color doesn't show up well. I think, so that's the darker red color, but I think I'm actually gonna change it to be lighter than the other one. I like the other one the way it is now. It's nice and bright. So let's see. So I guess it's this one. That's a red color. So let me just choose a lighter version. So according to the Cooler's website, this color, cd3e bbe91cb0. So they call that synopia. Huh. I'm not familiar with that word at all. Synopia. What is synopia? What's one of the faster ones? Let's do... phi3 is apparently kind of smallish. What is synopia? Please be accurate. And then the other one, wait, where did it go? Then I have the brighter red, which is EE1100, and that one's called off red RGB, so that's fine. And that one has the luminance rating 47, and this one has 45. But I think I just want to increase it much higher to like probably 60. So it's kind of a desaturated reddish. It's listed here as burnt cyan. So now if we prove again, that's much more readable. I like it. It's kind of low contrast, right? I do like it. I think I want to adjust it a bit, though. I think we could go even just a tad lighter. Let me try this. F5, so make it even redder and lighter. Yeah, that's nice. Does this show anything that I don't want to show? I think everything it shows here is fine, right? The logo changed. It used to show a regular Ubuntu logo, but now it shows an Xubuntu logo. And I didn't change that on purpose. Must have been an update. All right, so if we run prove, it says, okay, unmatched, square bracket, line 23. Oh, smart match is deprecated? Oh, okay. Well, let's find out what that's about. Smart match is deprecated. So this is Perl 5, smart match is deprecated. But that's not the actual problem, right? It's this unmatched square. Okay, so let's see what that's about. What is it? Lib? Okay. So we ran into a trouble here, right? So I have a square bracket here, but then it's saying unmatched. So what's that about? Oh, yeah, this regex flavor is rather different from the standard one I'm used to, like the JavaScript. The JavaScript regex flavor is the one that I'm used to. And the closer any other flavor is to the JavaScript flavor, the more I feel like I get it, kind of. So here, it looks like I'm trying to say, hey, if we matched a bang, or an at, or a colon, or a slash, then we will say errors 4. This one, punctuations not permitted. Okay, so these punctuations apparently are not permitted, we think. But it's not written correctly. And why is that? So we're using... Okay, so now let's go ahead then and get into the browser. Should we take a quick look at current events? Man, I hate these. I gotta be way, way more careful about curating whatever this is. Fewer, 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 fewer. This one might be okay. What is it? Bitcoin? Oh my goodness. Wow. Okay. Well, they've certainly written a lot, and they've tied together some things that seem like they could be tied together, but how exactly? Oh my goodness. Okay, well, interesting. Fuzzy notepad. I don't think this is a good choice either. All right. Well, let's not do that. Let's do Perl 5 regex doc. Okay. So this seems fine. Okay, so now we're going to compare to what I have, I guess. So I've got slashes, and then I've got angle brackets, and then I've got square brackets. Is that fine? I don't know. It's not totally fine. Something is not fine. Um, so I used a double squiggle, which apparently is the smart match. Let's maybe change it to the equal squiggle. Oh, invalid search string. Oops. Wait a minute. Oh, why do I use the double squiggle there? I'm trying to do a substitution. Okay, I'll leave that one alone for now. Okay, so now if we prove, what does it say? Okay, so unmatched on 23. Okay. So, you know, it's clearly intended to be matched. Okay, so now let's go back here. So we're looking for where we can list out like the characters that we want to match. No. Bracketed character class. So what was I trying to use the angle brackets for? I think they're out of place. Let's just get rid of all of them and see what that does for us. And I have an I flag. Where do the flags go? Oh, interesting. So yeah, so it's supposed to be much more similar to the regex that I'm familiar with, it looks like. So let's actually just change it. And even here, I've got a double dot here. Is that what it's really supposed to be? Um, yeah, it's supposed to be more like the regular ones. Okay, so I guess Raku has weird regexes, which I copied over, thinking that they might be what you use in Perl, but I think it was actually just a kind of a weird Raku thing. Okay, what about substitution? Is this doing substitution? Huh, interesting. Okay, let's look it up. Um, Perl 5 regex substitution. Okay, okay. So here, yes, I think we do want equals squiggle, but the flag G is going to go at the end, right? So we're replacing any amount of non-digits with nothing here. Okay, so now what about this one? We're replacing... Okay, so if we found any letter, then we die with error 3. If we found any punctuation, and for whatever reason they say punctuations not permitted, then we die errors 4. Okay, then we make a substitution. We get rid of anything that's not a digit. Okay, so then, oh, look at this. Double star. Okay, so it's interesting. So I copied this over from Raku, and Raku apparently was using a completely different sort of regex syntax. Not completely different, but pretty different. But we want to go back to more standard regex, like kind of we're just accustomed to, I guess. Okay, so what's this minus? It looks like this is strange. It looks like this is supposed to optionally be a 1. "11 digits must start with 1. Kind of a terse error message, but fair enough. Okay, then what about this one? So it was starting with a 1. Here it's an optional 1, but here we just want the 1. I was going to take this track off the playlist, but at the moment it actually sounds kind of nice. Okay, so here we're trying to do a substitution of the 1 with nothing. Okay, and that looks standard. Okay. So then here, we're going to be like, so if it's, so this is fewer than 10. Whoops. Is that it? I don't remember. I don't use this that much. I think it's like that. Let me just test it really quick in my browser. So, 1, match, start of line, digits, 0 through 9, end of line, and it says yes. But if I put a bunch more digits, so now I've got 4, should still match. Now I've got 7, should still match. Now I've got 9, should still match, but when I get to 10, now it doesn't match. Okay, so that's right. Okay, so yeah, let's leave that one. If it starts with a 0, cannot start with 0. Starts with a 1, cannot start with 1. And then in this case, the 4th digit is a 0. Exchange code cannot start. Yeah. That looks right. I think. Okay, now let's see what it says. So I've updated all the regexes. And it said, oh, it still says a problem on 23, but it's different now. So that's good, right? Syntax error. Dubious. Okay, let's see. Syntax error near the regex expression. Oh. Okay, so this is what it's like. Bang at :/ Not sure what the syntax error is there. If we comment that out, now what's it say? Scalar value better written with $. Okay, let's change those to $, I guess, then. $, it said, right? Okay. "11 digits must start with 1. Line 26. So it says fail. So it ran, but it won't work with, as long as this is commented out, that's not going to work. Whoops. So, do I know what the error is here? Whoops. Ah, okay. So, yeah, I think that's right. Oh, wait. Pearl Navigator? Oh my goodness, yes, don't mind if I do. Pearl Navigator, sure, yeah. Thanks for offering. Okay. All right. So let's look at the test now. So I think we tried this one and didn't have any luck. Oh, there's a whole bunch here, right? Yeah, a pretty good amount, yeah. So we're putting in a number, and it didn't fully work, right? So let's see if we can put in some prints. So cleaned number equals number. All right, so after we make this substitution, what we think that it's supposed to substitute any amount of non-digits with nothing globally. But is that actually going to work as we hope? I don't know. It seems like it probably isn't. So we're going to try to put... You think that's how it is in Perl? Put cleaned number? I don't know. Let me see what it says. Okay, so it's not like that, but Perl print... Is it printf? What is it? Okay, let's try it like that. Oh. Seems like the LSP is maybe a bit slow. Oh, it says syntax error. Uh-oh. Where did my Chrome window go? Alright, I'll bring up another one. It says syntax error. Print. Can't use string as a symbol ref while strict refs in use. Is that possible? Well, I don't see it print out. Okay, so I think I actually got it wrong. So, the regex, it says 11 digits must start with 1. But actually, it was not 11 digits. So errors 0 Error 0 is this one. Okay, so yeah, that one is for sure wrong. Um, all right. Let me take 2 minutes. I'm gonna think about what I did. Because I sort of copied from somewhere. Um, yeah, I just needed to stretch my leg for 1 sec. Okay. It was more than 1 sec, but it wasn't that long. Okay, so yeah, I was in a bit too much of a hurry or something. That's probably how I always am. But yeah, so this was meant to be something that's not one. Like this, right? So we match something other than 1 followed by 10 digits. All tests successful. There we go. In that case, let us submit. So I kind of cheesed that one, didn't I? Let's go to here. Okay, so that one is complete. Let's mark it off here. So that was Pearl. And we'll just paste that. Okay, great. Okay, so now if we go to history and we look at exorcism, all right, so according to this, I am missing the CPP nth prime. Okay, I should go back and do that next, probably. But to be honest, I feel like I'm not going to. I just want something fresh. So how many have I completed in total? 1, 2, 3, 4, 5, right? It's a start. It's a start. All right, let me come back in like 5 minutes again. BRB. All right, all right, all right. Let's do another one. Let's choose another one at random. I obviously I got to go back to those ones that I marked as come back to, but I don't want to this second. Let's just choose a fresh one. All right, let's close all of these and go back to exorcism. Okay. So we're gonna go random track. So it's gonna be unison. Hooray! This is an FP language. Not that many students. It's not one of their most popular tracks, but I do think it's a good one. A pretty good one. Let's choose a random exercise. Matching brackets. Uh-oh, it says it's a hard. So, I mean, it doesn't really sound like a hard. Is this one a hard in JavaScript? I don't... It's a common exercise, right? Let's see what it says. So I've done this one in Zig, Visual Basic, and Racket. If we look at it in JavaScript, it's an easy, right? Why is it a hard in Unison? I'm gonna be honest, today is a holiday. I'm not gonna try a hard. I'm sorry. I'm just gonna add it to the list to visit later. It's a horrible precedent because obviously I've got to do them regardless at some point, but yeah, it's an easy in JavaScript because it's what do you think is hard about it in Unison? Oh my goodness. I'm nervous. So it says the signature for the check balance helper function given for this exercise makes use of an ability requirement stack. The ability stack is defined for you, but the handler stack run is not. If you chose, you can implement the stack run, check balance, and is paired function. The tests will run even if you choose not to implement this exercise with abilities. So last time I did one in Unison where I had to use an ability, I really did struggle with it. It was D&D character. And this one's even listed as an easy, but I had a hard time with it. So you had to put this ability, this random ability on there, and I was quite confused about what I was even doing. And it took me a while. All right. And I didn't really learn very well, like, what even is an ability in Unison. So, let's choose a different one. This track has a ton of views on YouTube, if I remember correctly. Look at this, 59 million views. And I must say, it really is a nice track. It's really, really nice. All right. So this time, oh no, Reason ML? Okay. Okay, I'm not just gonna keep skipping. Reason ML is one of my least favorite, along with Faro Smalltalk that I did. You notice there's only 28 total exercises on this track. And I believe that the reason that there are few exercises on this track is because it's just a pain to work with. Compared to, like, look, compared to other FP languages, like, I really enjoyed Erlang. Erlang was amazing. Haskell was pretty great. Elm was fantastic. Elm really stood out as really nice. But some of these, like, Unison wasn't all bad, but it was difficult to grasp some things. But Reason ML, in my opinion, it just made a very bad impression. But let's see what the exercise is. So we're going to choose a random exercise, which is going to be Isogram, okay, it is listed as an easy, so I'm not going to skip this one. Let's just hop into it, and maybe it'll be fine. Maybe I'll realize that there's no reason to hate Reason ML. Let's see. Let's see. Maybe Reason ML is actually just fine. It made a bad impression on me, I must say. Okay, so we want isogram, right? Okay, so let's look at the README, I guess. Welcome to isogram. You know, I think on my Mac I set up Glow to paginate, to use the use the pager. Where's the Glow config? It doesn't have a man. Needs an argument. So do we have a Glow YAML? We do. What's in there? Style auto. Pager false. Why do I have pager false? I think there must have been some reason I wanted it false, but I think I do want it true now. Okay. This is much nicer. Okay. Welcome to Isogram on Exorcism's Reason ML track. If you need help running the tests or submitting your code, okay. So determine if a word or phrase is an isogram. So this one, again, is one that I did several times. Let's take a quick look. So I did isogram in awk. That was a pretty nice experience, I think. Let's see. So I did 3 iterations. So I guess I must have had a kind of a decent time with it. So here's my final iteration, I guess. And yeah, I like this. This is really nice, I think. So we decide we're going to lowercase because we want it to be case insensitive. I set the result to true to start with, and then we go through the whole thing, basically. So for I equals 1, I less than equal length, lowercase, and result equals true. I plus plus. So then we say the tail is going to be the rest of it. The C is going to be wherever I'm at. And then if the tail contains C, and C is a letter, then the result is false. I think I'd forgotten what isogram means. So isogram means it doesn't contain any repeats, I guess, right? Can I look again? No repeating letter. Okay, yeah, I think I had forgotten that that's what it was. What is this file handle here? Okay. Oh no, where's my... Oh, my video background is gone. Okay, let me choose another one. I'm going so slow. I feel like I've got time, but the truth is, like, I'm not catching up. I'm not on track to finish by the end of September at the rate that I'm going. Let me choose a new, different video background. How about... I'm gonna try choosing one from Euphoric Eugene on YouTube. Okay, yeah, this is a classic one. But we'll see how this looks. It's a little bit different. I like the animated ones from Chill Hop a lot, but let's try this one. It's a little bit different. So the number here is going to be 7. Let's see if that got something. Okay. So I did it in awk. That was a pretty good time. So we're just checking to see if a letter is repeated. And I mean, I think that's fine. We did it in bash as well. Let's take a look with 2 iterations. So here I just used grep. I mean, obviously that makes it simpler. And in reason.ml, presumably we can do basically the same thing. Just using a simple regex. So here we just are like, oh, hey, we just use a back reference. So with a back reference, it's a pretty trivial problem. I like the way I did it in awk, but yeah, using a back reference makes total sense. Here it is in JavaScript. Let's see if I did it with a back reference. Yeah, just a simple back reference, just like this. Let's see. We did it in Prolog as well, apparently. Let's take a look. Oh my goodness gracious. Okay. So no simple back reference this time, I guess. So we said is... Okay, let's see if I can read this one. I practiced quite a bit of Prolog because I was having a hard time learning to make anything work. Alright, so no dupes. So this rule, char and first rest, okay, sure. So not so different perhaps from what we did with awk, I guess. Oh my gosh, I don't remember what this arrow is for. I think this is essentially a kind of a ternary. So I think we're saying if the rest is empty, then I don't remember how we read it exactly in Prolog, but I think we can sort of read it this way. If the rest is empty, then char cannot be first. But if rest is not empty, then we will recursively handle that. So that seems fine. The Prolog syntax is still quite odd to me, but this is very straightforward logic, if I've understood it correctly. We're just, right, checking that the char is not this. It seems honestly pretty inefficient compared to how it was done in awk, I think, but whatever. And then it seems potentially kind of inefficient because it looks like we are going to like go through the whole thing. I guess we were really doing the same thing in awk. It seems like we're gonna go through the whole thing for every char. So if essentially we're doing it in quadratic time, which is not good. Realistically, we should use something more like a hash set so that we just go through and just add each one and then just find if there's a collision. We should solve it in linear time is what I'm trying to say by using a hash set. Of course, just use a hash set or just a hash map. But in this case, it's not. We don't need a map. Just a hash set would do. So yeah. So it's not a great solution. The regex way seems nice, like it's very terse. Do I have any where I try to for real do it? Yeah, here I just use a back reference. So again, you should be able to solve it in an efficient way just using a hash set and doing it in linear time. But apparently that's not what I did. What did I do in Rust? Maybe I solved it efficiently in Rust. Let's take a look. Oh no. What? Ah, it's another quadratic solution, isn't it? I didn't use a hash set here either. Did I do it in any of the previous iterations? I might not have even been thinking about it. Oh, that's crazy. Okay, so this time in ReasonML, let's try for a linear time. So, like, honestly, like, you could say maybe it probably doesn't matter. We're just using a 26-letter alphabet, so like whether it's linear time or quadratic time almost isn't even that important because we're using it's such a small alphabet. But like, come on. Let's just use a hash set and solve it in linear time because like we even doing? Like these are all quadratic solutions basically. I don't know how the regex engine implements the back reference thing, but I know it tends to be like supposedly kind of inefficient. Okay. So what if we were to do it? I haven't used Ruby very much in a long time. Ruby was one of the early programming languages that I kind of practiced back in 2018 when I decided I wanted to like be a programmer for pay, which it kind of worked out for a while. Kind of worked out for a while. All right. Or Go. We could certainly do it in Go. I like that. Let's just try it in Go real quick, because honestly, ReasonML kind of scares me. Honestly, in ReasonML, I actually am probably just going to try the regex back reference implementation, because it's just so terse, and I don't want to mess with ReasonML very much. I'm scared of it. Let's try it in Go. Let's do it in Go in just linear time. Okay, so let's go into our isogram, Go. Okay, it's been a while since I messed much with Go, but basically we're going to make a map. So we're going to say M is make map, and it's going to be a map of rune to empty struct. And let me go ahead and review. Uh-oh. Static check dispatched? Oh, I don't want to do that when I save the file. Hey. I don't know why that's set up like that. Oh, I've got extra square braces in there. Okay, so then we're going to go for and then is it CI range word? if m, and then it's if m c, or it's m. Okay, let me look at the map again. Yeah, we want this. So we're gonna say okay. We're gonna say if okay, return false. And then we're gonna say MC equals struct. And then at the end, we return. And I think that's it. So that should be linear time, and it's not even that hard, but let's fix these. Oh. And what's this one? Equals... Is it like that? Okay, let's test. Oh, we have to look at the case. Okay, so we'll use this. Duplicated hyphen. And then again, I think we have is alphabetic or whatever. Is alpha, something like that? No, maybe not. Yeah. There we go. Let's submit. Okay, see how that looks. Uh-oh, a little slow. It happens sometimes. Okay, passed. Let's mark as complete. Okay, so now, do I feel better about this? Let's just review it one last time. So, is isogram, we make a map, we go through the word. If it's not a lower alpha, we continue. If it's in there, we return false. And there we go. Linear time. That's the way it's supposed to be done, basically, right? Now we could nitpick some things. If we're going to nitpick something, I don't know. To be honest, I don't really feel like nitpicking much of anything. I think this is fine. I think this is pretty much the way it should be. I don't, like, maybe using make here. I think this is the way we usually do it in Go, but I'm not certain. But yeah, so this is, in my opinion, I think this is more like the way it should be because we're doing it in linear time using a hash map. All right. Okay, so now in ReasonML, I'm not gonna mess with that because I'm scared of it. I'm just gonna try doing it with a regex. So let's go to ReasonML. So let's go into our source isogram file. And here it is. Let is isogram. I don't suppose you think I've done any like BS platform could not be found? Darn. Where is my BS platform? So in the ReasonML track, do I have anything that I've done previously that might help me? Wait, this says exorcism.org/tracks/reasonml, but here it says unison. What's that about? All right, so we did hello world, we did leap, we did word count. I'm gonna look over these. Let's look over each one. Why did ReasonML leave such a bad taste in my mouth? So the hello world is fine. Like this is a delight. There's nothing wrong with this. Leap. Nmod 400 is 0, or Nmod 100 is not 0, or Nmod 4 is 0. That's fine. There's nothing wrong with that. That's totally cool. Word count. Oh my goodness gracious. Okay, this is the one that left a bad taste in my mouth. Ah! This is insanity. Oh my goodness gracious. This is the word count? Okay, hold on. So I did word count in what? ReasonML. Oh, that's the only one I've done it in. Surely, okay. Oh my goodness, this looks like madness. Word count. So a string comes in. We're gonna try fold left. Oh my goodness gracious. All right, so the good thing is we are using a regex right here, which is what I want to do in this next one. So what about anagram? Was anagram okay? Oh no! Oh no! Oh no! Oh, that's really bad. Oh, that's really bad. I did it in C sharp. Is it fine in C sharp? Let's look. Oh. Anagram is one that, like, it seems like it should be a pretty simple problem. I think if you use a prefix tree, it can be pretty simple. Right? Maybe? Maybe. I probably don't have any good solutions for anagram. Looks like I started it in Faro Smalltalk. I, I don't know why I would have done that. I probably didn't do that on purpose. Is it any better in Python? Oh, okay. This looks simple. Oh, because we used the counter. Did we do this one in Kotlin? I feel like... No, this one wasn't in Kotlin. All right. So this is anagram reason ML. So maybe it's not that bad. Okay. So I am going to try to use JS string match by RE. And I'm going to see how that goes. Oh wait, that's the interface file. We need the... Oh, we don't even have a implementation file, do we? Okay. So let is isogram equal W. We're going to go JS dot string match. I'm going to put %RE, kind of just copying. I'm going to put a string here containing the RE. So do we need to put the string itself in last? Okay, so I think it's like W here. It looks like, maybe? Yeah, I think so. And then here, we put the regex itself, which is just A through Z. We want a flag to make sure that it's gonna be case insensitive. And where's that flag go? I believe there. Not positive. And then here. Okay, so this is going to be a match group. All right, and then there could be any amount of stuff in between, but then we're going to find that same match group back reference, like this. Yeah? No tests found. Okay, so this is an odd little test runner, which I think is probably fine. It just depends on how you work. It's just a different way of working. Unison has something similar. All right, so we want to go to tests. Oh. Okay, so we need to do the npm-i. Let's see what it says. Okay, I don't think I want to do npm audit fix on this or anything like that. So let's just see what else is in here. So we did the npm-i. Okay, so now let's start the build process here. The module or file JS can't be found. Okay, so now, so we used the JS in word count, right? So in our buckle script, I can see, wait a minute. Uh-oh. There's a package JSON. Is that gonna have something we need? Okay, now it says no work to do. So is that good? Oh no, this is in the other project. Okay. All right. I set up all my key bindings. So let's see. No. All right, so let's look side by side here. Here's the package JSON here, and in my isogram, here's what I've got. So do they look the same? Yes, they look the same. Okay, how about the bsconfig JSON? So there's a little comment in this one, but it looks like it's all the same, I believe. Oh, wait a minute. Yeah, I think it's all the same. So let's npm run npm run build. Yeah, the module or file JS can't be found. So in word count, oh goodness, there's a lot in there actually. what's the word count BSJS? That's turned to JS, right? Okay. Okay. Okay, I'm not sure. I like this track too. Not a lot of views on this one, surprisingly. I really enjoy this track a lot. So it just says the module or file JS can't be found. So let's look at the help again. So we're supposed to do npm install, npm start, npm test. Okay. npm install. Okay. npm start, let's see what it says. Okay, so we found a bug. The modular file JS can't be found. Darn. Darn. So what did I do to make it work in the other one? The modular file JS can't be found. This is a part of what made me sort of frustrated with Reason ML. Now, like, you don't have to use JS stuff. It's just, like, what I found, I thought, was that it sort of made it easier. But there's some setup, I guess, or something that I didn't do. Module or file JS can't be found. Okay, so let's look. Reason ML, the module or file JS can't be found. All right. I might be missing something. Let me try this. Okay. So now if we try again, JS. So JS, I don't know, it's okay. Okay, so we tried doing this. There probably is something different. But what is it? Did we compare the package? Pretty sure, yeah. Um, so when we run this one, npm start, it says it's okay, right? Let's see. So what would make sense? All right, what else is here? So here I don't have a BSJS file, right? Because it wouldn't build my RE file, I guess. Oh, I don't. Shoot. Okay, I gotta step outside for a second while I contemplate this a little bit. All right, I'll be right back. All right, so clearly I don't know how to make the JS work, so I'm just going to try to do it in a way like the Prolog solution, basically. I don't love that plan as much as I loved the original plan, but the JS error is quite opaque to me at the moment. So let's look again at this word count thing. Or no, not word count, isogram. Isogram. So I looked at the solution that I submitted for Prolog, right? So let's try it with an approach basically similar to what we did here with Prolog. All right. So we'll have a no dupes function, I guess. And we'll, I guess, try to do it similarly to this. We'll see how it goes. Okay, so we're not going to try to do anything like that. We're going to try and say let no dupes equal, and we'll have a char, and then we'll have car and cutter here, but what is the syntax for that in Reason ML? Did I have anything in here that might maybe help? So we're trying to pass in a string here. So the char and then the string that is the rest of everything. Oh gosh. I didn't feel prepared to try to do this right now. Okay, concatenate. Sub. Okay, we can do this, I think. Oh no, I need more video. All right, let me pick another one. Yeah, this reason ML, I'm gonna finish it today. I think so. I mean, it's a pretty simple problem, obviously. I'm still not feeling happier with Reason ML, but I don't think that's like Reason ML's fault exactly. It's just my own skill issue, but uh, regardless, I've had a much better time with other languages like Elm, Erlang. I had a really good time with Erlang. Elixir and Gleam are nice, of course, too, but I actually found that I had the best experience with the regular Erlang, the OG Erlang. But they all seemed really good. Prologue was tough for me. Prologue was very tough for me. Um, which is crazy because like Erlang is not really that far off from Prologue, but it seemed nicer. Maybe it was just like the particular things that I was trying to do with it, like the particular exercises. All right. Let me choose something. Oh, here's one. I haven't done anything from this channel before. It's called Epic's Ambience. So these look kind of crazy. Huh. All right, I'll give it a shot. Okay, so char, rest, and then we're gonna say let, and we're gonna say car equal rest sub 0. Okay, so does that align with what they did here? Like this, right? So far, so good. And then we're going to use a sub, or excuse me, string.sub. And so we may need to use some module string. I'm not quite sure how that works. Because, like, I didn't have anywhere that I was trying to import JS. Wait a minute. Hold on. It's J with a small s? Was it that way the whole time and I didn't realize? Oh, oh no. No way. It was! Oh my gosh! Okay, let me go back. What the heck? I was freaking out over that. Over nothing. Over a small s. Ah! Okay, well, let's give it a shot. Okay, so npm install. npm start. And so now what does it say? Oh, does not match. Okay, okay. Um, so it's supposed to be string to bool, but I ended up with JS string t to option, so that's not good. Okay, great. We can fix that probably pretty easily. So Can we put a double bang on there like JavaScript? I'm not sure. Let's see what it says. No, we want oh wait, so it returns an option, right? Okay, let me see. So what did it say? It says we got an option array. So let me look it up real quick. So reason ML option. Okay. So if we were to go switch, is it syntax error? Okay, I think we're not supposed to have that. Is that better? Hold on, let's just put this into that. Is that better? Does that make more sense? I think a little bit. Okay. Okay, so I've got switch. So can we do a default like that? That might be the problem, right? It says syntax error line 6. Oh, I'm missing this. What the heck? Okay, syntax error line 6. Let is a reserve. Oh, it says syntax error line 7. Why is it saying bbe91cb0? We're looking for an exe? That's messed up. Everything's messed up. Oh, what in the world am I doing these days? I am completely missing this. Okay. It says ran all test suites. It says 9 failed. Why did this one not look like it ran anything? I'm not in a good mood all of a sudden. I'm not in a good mood. I hate watching myself make boneheaded mistake one after another. And like I've seen the pattern that causes me to do this. Like like I know what triggers me to make one boneheaded mistake after another, and it's being grouchy about working in an unfamiliar like environment and just like not having the ergonomics right. Which is the way it always is with Reason ML, which is why I haven't enjoyed using it for these exercises. But like you would think I could still slow down and be like, okay, this is an unfamiliar environment. Let's just slow down a little and not make one boneheaded, ridiculous, insane mistake after another. Maybe it's unrealistic. Like, I don't know. If I were 20, if I were 20 again and I had that young brain, would I make the same level of boneheaded mistakes? Honestly, yeah, probably I would. But I probably wouldn't feel as bad about it because when I was 20, my confidence was insanely higher than it is now. And I think that's natural. I think that's the way people kind of are. A lot of people. Okay. So, npm install, npm start, npm test. But when we ran the npm test here, it looked like, oh, okay, 9 failed. There we go. And yeah, it looks like it received the opposite of what it was supposed to every time. So do I just have it backwards? So if we match... Oh, yeah, I do have it backwards, actually. Okay, is that the last boneheaded mistake of the bunch? And the other thing is, like, I feel like people who are working professionally, they don't make boneheaded mistakes like this one after another. And I mean, I didn't. When I made some, it would depend on what exactly I was working on that day. But like the thing is, like when you're working with stuff that you're accustomed to, it's just different when you're not stretching yourself in the same way. Anyway, let's do it again. So now it says passed. So now we're gonna submit. The problem is I already decided that I wanted to try it the prologue way, and so I think I am going to still. But let's submit that first as the first iteration. Like, and it sucks. Like, making excuses for yourself or whatever, that really sucks. I hate that. But like at the same time, like if I don't have any excuse, then what even am I doing? Right? Like I don't want to be trying to make excuses because that sucks. All right, so it says passed, so I'm going to mark as complete. Okay, so that's reason ML. Okay, so I feel like I'm committed now, really, to trying in some way to, like, what am I trying to say? I feel like I'm committed to trying to do it the Prolog way, or the way that it was done in my Prolog solution. So let's jump in there. So without using any JS. So this is the first solution. But now this time, we're going to say let is dupe equal, and it takes a C and a T for tail, I guess. And then we're going to say let car equal T dot 0, let cutter equal T string sub. And now let's look again at how that was. Was it under strings, primitives? Primitives, I think. So strings. So we do string sub like this. Okay, so string sub, and we put the T in there, and then we put 1. I guess. Okay, so how's that look? Okay. Invalid argument if pause and len do not designate a valid substring. Okay, and we can do the len in, I guess, probably the same way, basically. Actually, where is the len? Okay, so then we say if cutter equals empty string, and then here we say C equals car, or not equals car. Or so it's if it's is dupe, so we say equals car. Else C equals car, or is dupe C cutter. Okay, so what else did we have in the prologue version? It was, here it was no dupes. Let me change that. That makes more sense. I was like, is dupe? Is that really what we want? No dupes. So we want not equal, right? So like that, right? And that's pretty much exactly what we have in here, right? Cool. I must say, the prologue syntax is nice and terse, right? Like, it seems elegant. It just seems a bit different. I'm just not accustomed to it. All right. Okay, so then I have is isogram and I have isogram. So where did string lower and string chars come from? Are those built-ins, I guess? I guess they must be, right? Interesting. I'm not sure I want to try to finish this in Reason ML, actually. I'm gonna have a hard time. Hate to say it, but well, I mean, actually, I don't hate to say it, but that is the truth. I know it's bad. Ugh. I used to, I used to want to see myself as a person who was kind of cracked, and I think by the standards of the time back in 2019, like I think I was kind of cracked actually by the standards of like the situation in which I found myself. But that's not the situation where I am now at all. So, and the fact of the matter is, like, if I can't, like, bring myself to do this, like, I'm not cracked at all. Like, I'm washed up. All right, I'm gonna step away again for a sec, and then I'm gonna pick another random exercise. I'm gonna pick another random exercise, but first let's check in with the Discord. I want to just see if anybody has said anything about a hackathon for this month. There was, a rumor started by the Discord owner, Lane. It was supposed to be a possible hackathon, but it was kind of presented as just a rumor and a possibility, not a sure thing. Okay, so I'm gonna close out of this. It's not part of the original commitment, it's not part of the hashtag 3 in Q3 challenge. So I'm just gonna set it aside for now. Maybe it'll be good for later. All right, so that was the end of my MPV. I'm gonna pick another one. I enjoy picking these video backgrounds. I actually thought that last one was cool. I actually am thinking that I like more motion in my video backgrounds rather than less. But it can't be too much. It can't be like an actual movie. But let's choose something else from Chill Hop, probably. Let's choose something from summer. Summer 2019, did they have a good animation for summer 2019? Oh yeah, that does look kind of good. All right, let's give it a shot. All right, a little too much text maybe. I think it's good. All right. So, what was I saying? Let's look at the Discord real quick. Zoom that up so it's hopefully visible. Nope, no talk about it. All right, that's fine. Yeah, really kill that tab. Okay, let's go to the next. So, tracks. We're gonna choose Unison. Okay, Unison is back. Okay, and the exercise will be all your base. All right. I'm not going to do Unison today. Forget it. It's a holiday. I do think all your base is a pretty easy one. It's basic arithmetic. I don't think we need any abilities or anything, but whatever. I'm not trying to do Unison today. Screw it. Ren? Ren is a really, really nice one. Ren is a delight. Intergalactic transmission. Let's see how delighted I am once I actually start. I should be able to finish this one today. It says it's a medium, but I'm not familiar with this exercise. Pretty sure I haven't done it, but I think I'll finish it. Probably. We'll see. We'll see. Oh, I am in the wrong place. Okay, let's look at our help. Says we're going to do ren-c package ren install. All right, just copy that. Okay, all good, it says. And then it says execute with ren-c spec file. Okay. Okay, failing tests. 1 failed, 25 skipped. Okay, so now let's see what the exercise actually is. Actually, I feel so much better. I haven't even started yet, but ren is nice. Okay, messages. So a cowboy was replaced with a clown emoji. Detecting corrupted messages isn't just important, it's critical. Ah, so it's a parity bit exercise. See, this is nice. This seems fun. Okay, let's see how it's going to be. So we're going to implement the transmitter, which calculates the transmission sequence, and the receiver, which decodes it. And we're just going to use a parity bit, sure. All right. So we want to be... the transmitters and receivers can only transmit and receive exactly 8 bits at a time, including the parity bit. The parity bit is set so that there is an even number of ones in each transmission and is always the first bit from the right. So if the receiver receives any of these, so 3 ones, 5 ones, 1 1, i.e. a transmission with an odd number of 1 bits, it knows there is an error. So we're kind of doing something with a pop count, right? However, messages are rarely this short and need to be transmitted in a sequence when they are longer. For example, consider this message. Since each transmission contains exactly 8 bits, it can only contain 7 bits of data and the parity bit. Okay. A parity bit must then be inserted after every 7 bits of data. Okay. So it's this part. Okay, so we had 2 bits here. Okay, so then we did this next part. And then we're going to do this next part, I guess. And then finally, we're going to do this part, it looks like, and then finish up with just 4. Okay, so 3 0 bits and the parity bit are added. All right, so hopefully this won't be too bad. We'll see. Okay. All right, so we have transmit sequence and decode message. And the message is, I guess, a string. Let's look in the spec. Oh, no, no, no. They're not strings. They're byte arrays. Okay, great. All right. So let me think about, oh gosh. Let me think about how we approach this one. Let me try and finish it today. Okay. looking for my pen. Let's see if it's here. I'm not going to be able to find a pen in here. Hold up. All right. Fine, let's look. So, we're going to want to look at just a pop count. And it's going to be 7 bits at a time. So I think we probably want to make use of recursion, I think. Just because that's going to make it easier to approach the problem. So essentially, what I'm contemplating there is we just handle the first 7 bits. All right. Then left shift all the remaining bits over by 7, and then handle them recursively. So let's put that into here. Nope. Just because that's just going to make it a lot easier to handle the problem. Recursion will make it much easier for me to reason about this problem, I think. And so the reason I think that is because I just want to handle the smallest sub-problem and then just, right, shunt that off. Shunt the rest of it off into the handle. So, that's not true actually, though. No, there's a problem. Shoot. No, I can't really do it with recursion the way I was imagining. Okay, so let's not. I can't really do it with recursion the way I was imagining. For some reason I was imagining, oh, I can just like pad it out into bytes, but then I'll be modifying the message. Okay. So okay. So we're going to go for each byte in the byte array. So 4, and then let's just look. So Ren programming language for loop. Control flow, let's hit it. Okay, great. So we're going to go 4 byte in message. I'm going to say processed message equals, it's like we probably use this, equals this. But again, okay, so if we go 4 byte in message like this, we still kind of have to handle everything. Like we we have to go through more output bytes than there are bytes in the input message. All right, so let's see. What I'm contemplating is like the simplest way to approach the problem is actually probably to go 1 bit at a time. And if I do think that that's the simplest, then that's what I'm going to do. So let me look again. So we can do we have like a range for, yeah, let's do this. So for I in 0 through 7, is 7 the most we have to shift? We don't have to shift over 8, right? So one bit at a time. It seems inefficient, but I think it is the simplest way to approach the problem, probably. Bit equals 0. So I'll have a bit keep track of where I am in the processed byte. Okay. And so then do we have bitwise shift, I'm thinking probably, right? I might not finish this today, but there's a shot. Shift. Okay, so yeah, we want left shift. Shifted equals byte shifted by I, right? Bit count, we'll do a bit count as well. Okay, so now here, process the bit. Okay, so is 1 equals shifted greater than or equal to, right? Let's just do that in hex. So that would be, what is it in hex? 8, so 8. Yeah, like that, right? So if is 1, bit count plus plus. Looks like we should use parentheses on that, so let's go ahead and change that. So let's increment the bit as well, the bit count. And we do have increment and decrement, or not, or no. Oh, maybe not. Do we have, let's see, syntax values. Okay, we might not have those types of convenience things, and you know what? That is okay. A bit simpler and more streamlined. So if we don't have this, then we can just, we're fine to just say, that's not a problem. Okay, so 4 byte in message, 4i in 0 through 7. Okay. So then if bit equals 7, so now we've put 7 in there. Process the byte. So if we're going to process the byte, we're going to say oh, you know, I haven't added processed byte equals 0 as well. So we're going to do that here. Processed byte equals. So we'll shift it over. And then so if it is 1, then processed byte equals, we'll just add 1, it's fine. We'll see if I finish this today. I feel like I'm making progress. It's kind of simple stuff, but I'm doing it in sort of a tedious way. Sometimes I'm like too like judgy, like am I doing this in a good way rather than like just focusing in. It depends on what I'm working on. All right. It's nice to be able to just really focus in, right? We all love that. Okay. So if bit count mod 2 is 1, first we want to shift it again. Processed byte 1. Okay, so now we've processed it, so now we have to add it to the processed message. So that is a list, and we can add to a list with add. Very convenient. Very convenient. So we're going to say processed message add processed byte. Okay. And so then once that's done, bit equals 0 again, bit count equals 0 again, processed byte equals 0. Okay, that may be close to the end of this part. So when we get down here, of course, we will now return processed message. Now let's look over it. Okay, so processed message is going to start as an empty list. We will initialize these values to zeros, bit, bit count, and processed byte. This is really like the bit index, and this is really like the pop count. So let's make a sub. So wherever we have bit count, let's make that pop count. I think that makes more sense, right? And then wherever I have bit, let's make it bit index. Okay. So processed byte is 0. Okay, so now we're going to go through each byte in the message in I 0 through 7. All right? So we're going to shift it over by nothing to take the first one, shift it over by 1 to take the second, shift it over by 2 to take the third, and so on. So we take all 8 bits. And we're going to say, all right, now there is another part at the end. There is another part at the end that I haven't done. So this is after we get to here. If the bit index is not 7 or is not 0, then we need to add the final byte. So if bit index greater than 0, add the final byte, right? And that's going to be So we're going to have to shift it over by some amount. So we're going to say processed byte equals processed byte shifted over by 8 minus bit index, right? And then if pop count mod 2 equals 1, let me check, mod is in here, right? Yeah, no problem. I must say, I really like this ren syntax. It is simple, as they say, but it feels very clean to me. All right, so then we processed message add processed. Right. Okay, so now let me look over this again, because I may have gotten something wrong. So has 2 1s, an even number, so the parity bit is 0. Okay, so that part I guess is fine, I think. So we haven't gotten to decode message yet, of course. But let's look over this. So we got to here. So 4 byte in message. We're going to shift these over. Okay, so now I want to shift it over so that the bit we're looking at is in the most significant position. I don't like the idea of doing it that way. I feel like we should rather right shift, maybe? Where is I? So we only are using I that one place. So to be honest, I would rather right shift here to put it in the least significant spot, I think. It kind of makes more sense to me. So this will be, we'll shift over by, is it 8 minus I? No, because that'll shift it all the way off, right? So it should be 7 minus I. So can we maybe just count the range backwards? Let's take a look. Where was that thing about the range? So a range may be backwards. Perfect, that's what I wanted to know. That's what I wanted to confirm. So yeah, so let's not do that. Let's just right shift by I, and let's just count backwards. Yeah, much better. That's not gonna work, is it? Because there should be some at the end. Oh wait, no. Yeah, that should be fine. That should be fine. Yeah. This makes sense. So what I was saying about some at the end is like this bit index is not going to necessarily get all the way back up to 7 at the end, and that's what this part is to handle. Okay. So, yeah, I like that better. So we'll right shift by I. I'll count it backwards. Bit index will be incremented to say where we're at. All right. So now we're going to shift the processed byte over. Okay, love it. Okay, now let's not do this. There, cleaner. So then we increment the pop count, and we add one there. Good with that. Okay. So then we shift this guy over again, because now we're going to add in our own extra bit. Okay. So this bit index, could it be 0? Oh, no, because that's what we just checked. Okay, love it. All right. Well, if I love it so much, then I'll try and do the decode message right now as well. Before testing anything. Big Bang. This feels like a good one for Big Bang. I am going to stop here at 1 o'clock my time. This should be good. All right, so decode message. So now the message that is coming in is going to be the processed thing. So some of this is, so we're going to go through a, the reverse process, basically. So the trick is that when we decode the message, if the parity byte, if the parity bit is not correct, then we need to, I guess, throw an error or something. So let me go out and let me try exorcism test. So it says one failed, does not implement processed message equals. Oh, interesting. Okay, static transmit sequence. Oh, okay, I messed up something very basic. So this is ren. Let's go to next. I think we have to use var. That's fine. So that would be here. So we have to use var. Okay, cool. What about in the for loop? Do I need something there? I would think it'd be the same. Let's look again. No, apparently not. Okay. That's a sensible choice, I think. Okay, so then this one again is var. Whoops. It is. But bit index is already declared. We're reassigning it, and we're reassigning this one. This one is var. Actually, I'm going to get rid of that one. That's simple now. Oh, not triple equals, my goodness. I didn't even really do that on purpose. Okay. Let's see what it says now. Okay, so it did pass one. Which one did it pass? Empty message? Okay. So now let's go into the spec. And let's see what we're skipping. Oh, goodness. So I want to say all of the transmissions are supposed to pass now. We'll see. We'll see. As long as we're not trying to decode yet. Okay, so let's not try to decode. Because I haven't done anything on it. Oh, gosh. Okay, great. 11 passed, 15 skipped. There, see? Slow down a little bit. Use a nice, cozy, comfy syntax. And there we are. There we are. I mean, I did spend a good amount of time on it. Okay. Let's go to the decode. Very exciting. Okay, so static decode message. I need to take a second. I need to see sunlight for a second. Why is it so far off the top? There. All right. I'm not gonna spend much more time. I don't think I'm gonna finish this one today. I don't think I'm gonna finish this one today. All right. I'll be back. All right. Okay, so 10 more minutes, basically. Not even 10 more minutes. So I think what I'm going to do is I'm going to not even worry about the parity bit at first, because I don't think I'm going to finish it today. I'm not going to finish it today. So I'm not going to worry about the parity bit at first. I'm just going to try to do a happy path decode, ignoring the parity bit. Get those to pass before checking the parity bit. All right? So initially, I will just do a happy path decode. This is a really good track. I love this track. Ignoring the parity bit for now. Okay, so that's fine. So let's go for byte in a message. And it's going to be a very similar idea. So we're going to need, again, we're going to need a list of bytes for our decoded message. Are we going to need this? A bit index? So we're not going to worry about a pop count, but we will still need, I think, the bit index, I guess, and we will still need probably the processed byte. Okay. And we'll need the pop count after, but let's not do it yet. So I'm going to say var decoded message equals, and we'll start up that off as empty list, all right? We'll say var bit index equals 0 and var decoded byte equals 0. All right. So then here, we're going to say for I in, and we're going to do again the same range, 7 through 0. Right? Wait a minute. Do I need this? Yeah, I guess so. Oh, but here's the thing. If I'm ignoring that guy, then I can actually just ignore it right here. But if I do that, let's for sure make a message. Note, the 1 at the end of the range will need to be changed to 0 when I stop ignoring the parity bit. All right, so let's make that message. Actually, that's kind of a verbose message. Let's just say, let's do it differently. Let's put the 0 there so that it doesn't have to change. But then let's just say if I equals 0, this is the parity bit, ignoring for now. And then I'll just say, I guess, continue. Is that what we want to do? And it said continue, right? Let me just take a look. Continue. Okay, that seems fine. Okay, so that's good. So now if it's not the parity bit, then we're going to process the bit. Okay, so let me remind myself of how I did it here. So we shifted that guy over. So let's say var shifted equals byte shift I. So we'll do a right shift like that. And then we'll say decoded byte will add on to there. So decoded byte equals decoded byte plus shifted mod 2. So we'll add 1 there if it's wanted. And then once we've done that, we will shift the decoded byte over. So bit index equals bit index plus 1. Okay. So now we're going to go if bit index is 8, the decoded byte is complete. So that's what happens there. So at the end, we are going to return decoded message. So at this point, we are going to say decoded message add decoded byte, and we're going to reset bit index equals 0 again, and decoded byte equals 0 again. All right, so now where do we shift the decoded byte over by 1? Do we do it here? I want to say we don't do it when the bit index is 8. Or do we? I think we do it right here. Let's look. Shift the decoded byte over to set the least significant bit. So here, where did we shift it? We shifted the processed byte right up here. So yeah, that's quite similar. So are there going to be any leftover bytes? No, there's going to be nothing left over. So if we ignore the parity bit, then the decode function is quite a bit simpler. Let's look it over. I'm basically at the end. I am going to log off. I'm going to stay on it just long enough to see if these pass, I guess. Okay, let's look it over. Decoded message, bit index, decoded byte. Okay, makes sense so far. So this is the parity bit, ignoring for now. So then we right shift. Then we left shift this guy. We do this. We increment the bit index. If we have reached 8, then we're completed. And we do that. That might be it. Ignoring the parity bit again. So let's look at the spec. Okay, so if it's the wrong parity, that's not going to work because we've ignored that. Wrong parity I'm going to ignore. Let's see, I'm nervous. Expect method... Okay, I missed a brace somewhere. $15 passed, 11 skipped. Okay. So... Oh, I do want to do empty message, zero message. Let me do some more of these, but I think it's going to pass, and then I'm going to totally log off. And finish this, I guess, probably tomorrow, because I'm not going to come back on later today. It's a holiday. Okay, so this one should be due. Okay, so I'm skipping wrong parity because it's not implemented. Okay, so 22 passed, 4 skipped. Okay, I'm gonna log off that. That's actually, I really enjoy that exercise. It's actually a fun one. That's all I have to say. So long.